In 6.2, we are going to solve right triangles and do some applications of trigonometric functions. So in problem number, this is 6.2, number 1, we're going to solve the right triangle. And when we solve a right triangle, we need to know what all the remaining sides and angles will be. So I'll go ahead and sketch that here. And we have 30 degrees is angle A. Angle C we know is 90. Angle B would be 90 minus 30, which is 60 degrees. So we've already got one. And then we're going to find A and B. First we have little c is equal to 8. So we're going to solve for A and B. So using what we know about 30, 60, 90 triangles, a 30, 60, 90 has a ratio of 1 square root of 3, 2. Right. So we will let A be 1x because it's actually it's a ratio, so we're not sure what x is, but so we'll put 1x. B will be x times the square root of 3, and C will be 2x. Now we can solve for x because we already know what the hypotenuse is. Since 2x equals 8, we know that x is equal to 4. So the sides are, draw another sketch here. We have 8, 4, and 4 square roots of 3. And then this is a 30, 60, 90. So over here we have angle B is equal to 60 degrees. Small a is equal to, let's see, that was 4. And B is equal to 4 square roots of 3. It says round to the nearest tenth, so we're going to have to express the square root of 3. My calculator, 4 times the square root of 3, which is 6.9, rounded to the nearest tenth. Okay, in question 2, solve the triangle. We have the right triangle. ABC. C is the hypotenuse. Side B is 125. And so we need to find little a and little c. And we know that angle B is 63.1 degrees. So to find angle A, we know that since C is 90 and the sum of all the angles of a triangle is equal to 180 degrees minus 90, that leaves us 90 degrees for these two angles, these two acute angles. So A is 90 minus 63.1 degrees. In other words, A and B are complementary because the two angles add up to 90 degrees. So 90 minus 63.1 is 26.9. And then to find little a and little c, we can use one of the trig functions. So we have angle B already known. And so a trig function that uses one of the known values of 125, that's one of the sides. So that's opposite of the angle in question. So to solve for A or C, we could just use a trig function that uses opposite. So I'll just start with sine of 63.1 degrees is equal to opposite, which is 125 over hypotenuse, which is C. Solving for C, we multiply C both sides. Solve for C, and we get 125 divided by sine of 63.1. So C is equal to 140.2. And to solve for small a, let's see, we know that large A, that angle A is 26.9. So we can use sine again, or we can just use the two green known values. We have some choices here. So if I just stick with 6310 and use A, we know that that is adjacent to that angle. Okay, so, and then the 125 is opposite. So we can actually use the tangent of 63.1 degrees is the opposite side, which is 125 over A. So A is 125 over the tangent of 63.1 degrees. And we have A is equal to 63.4. Nearest 10th. All right, so I'm double checking my work. Triangle ABC, we've got 90 minus 63.1 is 26.9. So we've got angle A is correct. And we want everything rounded to the nearest 10th for A and C as well. The sine of 63.1 is the opposite, 125 over hypotenuse C. So C is 125 divided by the sine of 63.1. And so C is equal to 140.2. So, oh, it looks like I have a typo there. So 140.2. And the next question I want to go on to is number 3. We want to solve the right triangle, and here we have degrees and minutes. All right, so we have angle M is 43 degrees, 30 minutes. And so because M and P are complementary, we know that we can subtract 43 degrees, 30 minutes from 90. So 90 degrees, if I were to split that up so that I can subtract the degrees and minutes, we can rewrite that as 89 degrees, 60 minutes, because we know that 60 minutes is equal to 1 degree. And now we can subtract the 43 degrees, 30 minutes, and we're left with 30 minutes. And this is 46 degrees, 30 minutes. So that's angle P. To find small n, we can take this angle here, and we can see that the side opposite is known, and we're looking for the hypothesis or the hypotenuse, which is n. Okay, so this is the opposite, this is the hypotenuse. So we have the sine of 43, and I'm just going to write this as a decimal, plus 30 over 60 is equal to the opposite, which is 21.4 all over n. So to solve for n, we have 21.4 divided by the sine of 43 plus 30 divided by 60. So n is equal to 31.1. And then to solve for P, we want to solve for P. So P is the adjacent to the angle that we know. So adjacent over opposite would be the cotangent, or we can do opposite over adjacent, which is tangent. So we can say that tangent of 43 plus 30 over 60. So the tangent of the angle is equal to the opposite over the adjacent, which is little p. So p is 21.4 all over the tangent of the angle. And that's equal to 22.6. Is that a 46? Sorry for my typo there. That's a 46 degrees, 30 minutes. Okay, so I'm going to go ahead and check all my work. We have 41 degrees, 30 minutes. Oh, is that what I did wrong? Oh yeah, I typed that in wrong. But okay, so instead of doing it all over, I'll let you do your problem with your own numbers, knowing this is the process. But we did this correctly. If we were using 43 degrees, 30 minutes. Okay. And the next problem I want to do is number 5. We want to solve the right triangle where A is 86 degrees, 42 minutes, and little a is 13.75. So to find the angle B, let's go ahead and sketch this. Okay, so let's see. We have the angle 86 degrees, 42 minutes. We want to subtract from 90 or 89 degrees, 60 minutes. 80, sorry, 80, yeah, 80. So we want 90 degrees to be 89 degrees, 60 minutes. We're going to subtract the known angle, 86 degrees, 42 minutes. And so we have 18 minutes left, and 9 minus 6 is 3. So we have 3 degrees, 18 minutes for B. Okay. And then, let's see, we need to find little b and little c. So to find little b using the known angle, and we do know 2 angles now. So to find little b, that's the adjacent side, and we know the opposite, so we can use the tangent for this. So the tangent of 86 plus 42 over 60 is equal to the opposite, which is 13.75, divided by adjacent, which is little b. So b is 13.75 divided by the tangent of 86 plus 42 over 60. And we have 0.7928. Round to the nearest hundredth, it's 0.79. And then to find little c, we can use the Pythagorean theorem, but I prefer to try and make it as precise as possible using the known values in the problem as opposed to an estimate or a rounded number. Okay, so we're going to solve for little c. And I can see that the angle here and c, that's the hypotenuse. And we know that this is the opposite across of it. So the opposite over hypotenuse is sine. So the sine of 86 plus 42 over 60 is equal to the opposite, which is 13.75 over hypotenuse, which is c. So c is 13.75 divided by the sine of 86 plus 42 over 60. And we have 13.7 or 13.77 if we're rounding to the nearest hundred. Okay, and let's just see if it all makes sense. So the hypotenuse is 13.77 and the smallest side is 0.79. I can see that the largest side is across from the hypotenuse, so that checks. And B is a smaller angle, so it should have the smaller of the two legs. It should have a smaller side. So that looks pretty good. All right, that was example number 4. In example number 5, we are only given a couple of sides and we need to solve the entire triangle. So let's see, here's A, C, there's B. Little b is 100, little c is 450. We want to know what is A, and then we have to find the angles. So to find A, we use the Pythagorean theorem. So A squared is equal to 450 squared minus 100 squared. Let's go ahead and work that out. 450 squared minus 100 squared is 192,500. We take the square root of that. So second x squared. So we take the square root of the answer and we get 438.75 rounded to the nearest tenth. A is equal to 438.7. So we found A. Now we're going to look for the angles. So we could take any of the trig functions here. Since I already know 100 and 450, I'll just use those two. And so that's adjacent and hypotenuse. So cosine of A is equal to the adjacent to A, right? If this is the angle in question. So it's 100 divided by 450. So A is the arc cosine of 100 over 450. Another way to write that is that A is equal to the inverse cosine of 100 over 450. Just don't use that -1 as 1 over cosine because that's not what that means. It just means it's the inverse function or the arc cosine. which returns a value of 100 over 450 to an angle. So we want to know what is the angle. So we're going to press second cosine 100 over 450. And we have 77.1 degrees. Rounded to the nearest tenth. And to find B, we just merely subtract that from 90. So 90 minus that answer. Oh, and I think we're rounding it to the nearest tenth. So this actually needs to be a 2 here. Okay. And when we round that, we get 12.8 degrees. So we have angle A, angle B, and a little a. Now we have solved all 6 parts of the triangle. Let's see, that was number 5. I'd like to look at, see what number 7 looks like. I think we're okay there. And then the next one I want to do is number 9. And so here we have an application for solving triangles. An aerial photographer who photographs real estate properties has determined that the best photo is taken at a height of approximately 464 feet and a distance of 849 feet from the building. What is the angle of depression? So to understand angle of depression, say we are a plane and you're flying at a horizontal, right? If it starts to descend, the angle of depression would be this right here. And this is my height. And we can draw land here, okay? So this could be some distance here, and this could be height, okay? So the angle of depression is off of the horizontal line. And so this is the angle of depression. So in this problem, we have our triangle showing the height, which is 464 feet. And normally you're going to have to draw the problem, but here they're doing you a favor and drawing it for you, but we will have to sketch many of these problems out. Let's see, we have a distance of 849 feet from a building to this photographer, this plane up here. So from the building to the plane is 849 feet. Okay. So the angle of depression is formed from the horizontal. Okay. So that angle right there, that's what they want to know. What is that angle? Now, if you recall about 2 parallel lines that are cut by a transversal, we do have that. Here's one line and here's the other parallel. And the transversal is this line right here. And so the rule is that any 2 parallel lines that are cut by a transversal will form some congruent angles. So the angle of depression will equal the angle of elevation at the base. And that's because these two angles are called alternate interior angles. So if we can find out what the base angle is, we can find out what the angle of depression is. So we have our right triangle, and we have two sides that are known. And so we can use trigonometry to find out what the angle of elevation is at the base. So if we have the opposite side and the hypotenuse, we can do the sine of theta is equal to 464 over the 849. So to solve for theta, we have the inverse sine or the arc sine of 464 divided by 849. And so that angle is 33 point, let's see what they want, to the nearest degree. Okay, so 33 degrees. Therefore, the angle of depression is also 33 degrees. Let's hope I'm right here. Okay. The next problem I want to look at is question number, some of the application problems. There's a few in the back of the homework, like 12. Let's look at number 12. So for this one, while visiting a memorial, this is number 12, while visiting a memorial, a person approximated the angle of elevation to the top of the memorial to be 34 degrees. After walking 255 feet closer, he guessed that the angle of elevation had increased by 17 degrees. Approximate the height of the memorial to the top of the memorial. So I would definitely sketch this. This is such a very important thing to do for chapter 6. Anytime we're solving triangles, we really need to sketch everything out. So to show, let's see, here's that. Here's the top of the memorial. We have a 35-degree base angle there. And then we have 51 degrees here. And this piece is 255 feet. And so I'm going to read this problem again. This is one of George Polya's methods of problem solving. Understanding the problem is very key. So if you have to read the problem a couple times, sketch it, guess, do whatever you need to understand a little better. So while visiting a memorial, a person approximated the angle of elevation to the top of the memorial to be 34 degrees. We've got that. After walking 255 feet closer at the base there, he guessed the angle of elevation had increased by 17. So 34 plus 17 is now 51. Approximate the height of the memorial. So we want to know what is the height here. So now we have our right triangle, and there's H. I'm not sure what this distance is, so I'll just call it X. Okay, so now I've got my right triangle defined in this larger outline here. Okay, and so we need to solve for H. Well, it looks like I've got two triangles that I can solve, that I have two right triangles. I have the larger one, but I also have a smaller one. Okay. So we have these two triangles to help us solve for H. So if we use the large triangle, angle 34, across from that is the opposite, that's H. And at the base, that's our adjacent. Okay, so this is the adjacent, and this is the opposite here. Okay, that's the opposite side. So we know that tangent of 34 degrees is equal to opposite, which is H, over the adjacent, which is X plus 255. If we solve for H, we get tangent 34 times X plus 255. Now let's get the other triangle. The blue triangle. So tangent of 51 degrees is equal to H over X. If we solve for H, we get X times the tangent of 51 degrees. Now that we have H, so we've solved for H, we can now set the equations equal to each other to solve for X. So X times the tangent of 51 equals X tangent 34 plus 255 tangent 34. I need to group the X's to one side. So we have X tangent 51 minus X tangent 34. Of course, that's degrees. And that's equal to 255 tangent 34. If we factor the X out, we're left with tangent 51 minus tangent 34. And then finally, X is equal to 255 tangent 34 all over tan 51 minus tan 34. Make sure that's in parentheses because you're dividing by the whole thing. Go to your calculator and see what you get for X. So we have 255 tangent 34 divided by parentheses tangent 51 minus tangent 34, and then close your parentheses, and we get 306.9. And just round it according to what the instructions tell you. It says round to the nearest whole number as needed. So we have 307. So X is 307 feet. The other problem I'd like to look at is, well, you know what? I think this is a pretty long enough video, so I'll come back and maybe do a couple others. So I will leave for now.